Okay, done. So now I will try to explain you all these things now. Okay. So yesterday I have taken an example of a pressure cooker. Okay. And heating it, I have plotted a certain plot on a PV diagram. Correct. And the plot was, it was a constant volume. So the plot was something like this. Correct. Yeah.
Yes.
So now we shall see what is the meaning of a word state. Okay. Now, in order to blindly represent this particular thing here, that is your process, I will even say what is a process after that. For an instant, this is your process, which moves, okay, on a PV diagram. For this process, in order to completely define it, I must indicate two states of it. The initial where it has started. So this particular point would be of initial, correct? And the other point where it has ended its transformation or its process, that is your final state. Okay, and these two states will generally be in equilibrium. Okay, these two states will generally be in equilibrium. Equilibrium in the sense it will not change its states further, nor it will be having any physical distraction, nor it will be having any chemical changeover. Okay, all those things will never happen. So the system becomes equilibrium, will not react further. So that is what it is meant. So I have used, if you have heard my explanation while explaining the initial state and final state, I have used the word state over there. Yes. So initial is a state and final is also a state. Okay. So what do you mean by state? State is something like in the process, if I want a particular point here like this, it is a series of states it goes through. So this might become a state here. This is also a state, a state, a state, a state, state, state. State is nothing but it is a presence of extinction. So where it has been existed in that particular point of time. So I have started heating here, it has ended here. At this particular state, what is the pressure? If that is my question, so you can just plot it on back to the P and V's, so you can get the values from that. So state is something which is very much what is the existence of that particular period of time. That is known as a state. Okay, so if a process is going on like this, it might be anything. As in case of isothermal, it would be going on like this. Okay, for analyzing the process, I will be calling it as, I will be naming certain states, like this as a final and this as an initial state, is it? So if the process is going in this direction, this would be final, this would be initial, and this would be final. So if that is the case, I would be naming it as something like 1, something like 2 here. So 1 indicates what is the existence at state 1. 2 indicates what is the existence at state 2. What are the different properties at state 2? What are the different properties at state 1? Now, how am I supposed to calculate the different properties at state 1? So what I must do is I must just draw a line like this, okay, so that I would get the value of the pressure at particular state 1. If I want the volume, I should just come down so that I will get the volume at state 1. Similarly, it goes for the state 2 also, where you can find different values of pressure and volumes. Okay. Yes, here it is. Hope it is clear, right? You can see the things? Okay.
Yes, sir.
So thermodynamic state point and state diagram. So whatever the plot we have drawn there, it is nothing but your state diagram. That means how the state has been continuously changing over the period of time. So for the period of 5 minutes, for the period of 10 minutes, how the state is continuously going changing. So every point on the plot, that is every point on the plot would be of each and every state. State is nothing but the way it is existed. That is nothing but your state. Okay. So you can just take the diagram and even the definitions of this. Okay. And intimate me once it is done. Yes, completed. Done. Okay. Okay. So next, we will be discussing about the path and the process. Okay. So according to the definition of the path, what he states here, the path is defined as a thermodynamic process path is the series of states through which a system passes from initial equilibrium state to the final equilibrium state. Okay. And can be viewed graphically on PV, PT, and TS diagram. Okay. So when the path followed by a system during a change from one equilibrium state to the another equilibrium is completely specified, that is initial equilibrium state, final equilibrium state, and state of energy interactions with the surroundings, then such path will be called as a process. So this is the statement given in your notes. I'll give time take it down. Now, let us understand what he says actually. Okay. So in the same old example, I have said that there is a process occurring from initial equilibrium state to a final equilibrium state, which has a series of states in it. Okay, it goes with a series of states in it. Each and every point on a path where the system is going is a state. Okay, state is nothing but how it is existed on that particular point of time. So that is your state I have set. Suppose for some system X, like there is some system X like this here, which undergoes some sort of some sort of thermal reactions in within itself. And when I try to plot the PV diagram of this particular system, it is as such, like this. Okay. So this particular PV plot here gives the series of states, that is series of states through which it has passed like this. Okay. The system, when it goes with the time, these are the series of states through which it has passed. Okay. This is nothing but the path of the system. Okay. So path is nothing but the series of states through which it has passed. But when I can say a path to be a process, all the path which is followed by a system cannot become a process. Process is something specific in nature. I mean to say, so if I say there is some system X here, okay, which is following certain path like this, I will specify here, this is my initial state. This is my initial state. And this is my final state. Okay. During the energy interaction, during the changeover of paths from initial to final, it has interacted with the work and heat to the surroundings as so and so 100 kilojoules of work is being given out. 100 kilojoules of heat has been taken inside. Okay. If I specify all those things, then your path will become a process. Okay. So path is something which is just a series of states which has passed through. But when you want to specify a path as a process, then what you have to do is you should completely specify it. Whatever the required data for that particular path, you must give it. Like in the sense, you must specify what is the initial state. You must specify what is the initial state, what is the final state, and how it has gone through. Whether it has gone horizontally, keeping the pressure as a constant, whether it has gone vertically, keeping the volume as a constant, whether it has gone hyperbolically, keeping temperature as a constant. You must specify all those aspects. So then your path is specified with all the requirements. Then you can say this particular path is your process. Okay. So that is the thing. So take the notes. If you have any doubts, you can just call me up. Same thing. Just intimate me once it is done. Completed?
Yes, sir.
Okay. So yes, what is the difference between a path and a process? Nilesh?
Yes, sir.
Nilesh.
Yes, sir.
So what is the difference between a path and a process?
The path is through which the system passes from initial state to the equilibrium state.
Okay, correct. So then what is a process? If I want to say a path as a process, then what is the conditions required?
Where the interactions are made in the surrounding.
So that you need to specify, is it? You need to specify the energy interactions while it has gone within the path, that specific path. You have to specify how much energy it has interacted with its surroundings. You must even specify where exactly is your initial equilibrium state, and even you must specify where exactly is your final equilibrium state. Then that particular path through which the system has been passed will be called as process. Okay, that's great. Chandan C. Chandan. Okay, just not there. Nafa Abdul Rahman. Nafa.
Uh, no, no.
Hello.
Yes, Abdul. Understood the concept of path and processes? Nafa Abdul Rahman. Amit Lahari.
Yes, sir.
So, what is the difference between a path and a process? When can I say a path to be a process?
Path is like steps of process. Steps which has to be completed.
So, when can I say path to be a process? Man? Faster network connection. Are you able to hear my voice?
Yes.
Amit, yes, man. Okay, just read out the definitions for me at least. At least read out the definitions from the screen itself. What is a path and when you can call a path as a process? Read out the definitions, Amit.
Thermodynamic process path is the series of states through which a system passes from initial equilibrium state to final equilibrium state.
Okay, got the meaning of it? It's a series of states, one after the other. How the system performs in that particular period of time is plotted in a form of a path. Next, when a path followed by a system, just
When a
read
path,
that.
yeah, when a path followed by a system during change from one equilibrium state to another is completely specified, then such path will be called a process.
So, what we need to specify that? If a path has to be called as a process, what we need to specify?
The equilibrium state.
Okay, initial and final equilibrium states and the energy interactions. Thank you, Amit, for all that. Okay. point functions and path functions is your next topic. Okay. Now, we shall take an example of a turbine. So this is your turbine. For this turbine, you are supplying the steam in, and which is of high pressure, and you are taking out steam out steam, which is of low pressure. Okay, because there is a reduction in the pressure, the entire pressure is being utilized to give the power output. Like this, there will be a shaft connected to a generator, is it? There will be a shaft connected to a generator, and the shaft would turn like this. Okay, the shaft would turn because of the high pressure steam. So whatever the difference in the pressure, so I will say the pressure which is going inside is P1 and pressure is going coming out as P2. So the difference in the pressure, which is P2 minus P1, the total amount is being transferred as the turbine work output. Okay, so this is the funda which is going on in the turbine. Now, if I try to plot the PV diagram of the same thing, okay, if I try to plot the PV diagram, it looks something like this, where this particular point is your initial state, which is here. Here the pressure is, this is state 1, and this is state 2, which is at the exit of the turbine. So these are here is your state 1 and here is your state 2, and same thing, here is your state 1 and state 2. Okay, during the turbine, during the course, the steam enters and starts to change its states in the turbine. We have this process here which is clearly defined. Okay, like this. Okay, so P1 is your pressure at initial and P2 is your final pressure. Okay, during this course of time, it has generated a work output like this. Okay, it has generated the work output, which is known as a turbine work output. So W2 is nothing but work output from the turbine. Okay, so this is one of the concept here. Okay, and this particular point which I say now is very important. Carefully observe it in order to understand what is a point function. In order to understand what is a point function and what is path function. So that is what I am trying to explain you. Okay, listen here. If I ask you the question, what is the pressure at state 1? That is here. So what if I ask you the question, what is the pressure at state 1? What you will do, you will just go back and give me the value of whatever it is the value. So P1, if I say it is as something near to 100 and this is something near to 20, you would say me, the pressure, sir, the pressure at state 1 is 100. If I ask you, what is the volume at state 1? If I ask you what is the volume of state 1, you will go down like this, and whatever it is the value on the scale, you will say me, that is the value at state 1, which is V1. Okay. If I ask you, what is the pressure at state 2? What you will do, you'll just go back and give me the value of pressure 2. That means, in order to get the value of pressure, just a state is enough. If I just specify the state, you can give me the value of pressure. Same goes with the volume also. If I just specify the state, you can get the volume what it is there. But if I ask you, what is the value of work done? Okay, if I ask you what is the value of work done here, you must analyze the things from state 1 to state 2 like this. You should analyze the complete things from state 1 to state 2. Complete things. You have to analyze the things and then give the data. That means the value of work output is dependent on the path. Okay, it is dependent on the path, and your value of pressure is dependent just on the state. So, your work output, which is dependent on the path, is known as a path function. And your pressure, which is dependent just on the state, is known as a point function. Okay, got the meaning? What is point function? What is path function?
Yes, sir.
Clear, right?
No,
So
sir.
that, yeah. Any doubts?
Can you explain once again, sir?
Yes. So definitely, I would say once again. I will give you one more example to make you understand. Okay.
Okay, sir.
Yeah. Okay. Now, there is a beaker, and I am heating up. Okay, the water in it. And I will try to plot the same thing, whatever the system in the sense here, this one would be the total system. If this is my total system, whatever the series of states it has been passing through, I will just try to plot on a TS diagram for this instance. So TS diagram is nothing but temperature versus entropy diagram. So T is your temperature and S is your entropy. Do not much worry about what is entropy and all. We shall discuss slowly, one after the other, in the coming classes. Okay. Now, if we try to plot the TS diagram of wet when the boiling for water, it would be something like this. Okay. It would be something like this. So I must specify the initial state as it. So this is my initial state, guys, which is state 1. And it has gone to the series of states. When I goes on increasing the heating, it goes into the series of states and it has reached the final state, state 2. Okay. So if I ask you the question, Rakshan, are you there?
Yes, sir.
So if I ask you, what is the temperature at state 1? What do you do?
Pick the graph and
You just pick the state 1. Yes, you just pick the state point number 1 here and go back to get your temperature at state 1. Correct? Simple.
yes, sir. Yes, sir.
If I ask you the question, what is the entropy at state 2? What you will do? You will see where is my state 2? Here is my state 2. And I will go and plot it on the entropy axis to get the value of the entropy at state 2. That means in order to get the values of temperature and entropy, you just require a single damn point. Got it?
Yes, sir.
So just by specifying a point on a diagram, you are able to get the value of temperature and entropy. But what is the work carried out? If I ask you the question, what is the work carried out? You are inputting some work, is it, into the system? And how much heat you are inputting into the system? If I ask you the question, how much heat are you going to input into the system? Then you must analyze the path of it. Got it? You must analyze the path, how it has gone like this. Okay. So when I ask you a question, what is the heat of it? You are going to just not look at a point, but You are looking at the entire process. You are looking at the entire path of it. That's why your heat is a path function.
Okay, sir.
Got the meaning?
Yes, sir. Yes, sir.
So we have discussed five parameters, I guess: pressure, volume, temperature, entropy, and heat. So I told you in the last example, your work is also a path function, is it? And your heat is also a path function. In order to determine heat, what you have to do, you have to look at the entire path which has followed. Without that, you cannot even judge what is heat, correct? So
Yes,
that's
sir.
why heat becomes your path function, temperature and entropy becomes your point function. Got the meaning?
Yes, sir. Yes, sir.
So that any doubts here, guys?
No.
Okay. Anyone else? Okay. So just take the notes, not this. Yes, here it is. And exact differentials and inexact differential, the concept of that, I will be explaining you in the next coming class. Just take the notes totally here. So from starting from here, just take the notes for all of this. In the next class, I'll be explaining what do you mean by exact differential and what do you mean by inexact differential. Okay, just take the notes. Even D is represent exact differential, delta is used, and all those things we'll be discussing. As of now, just take the notes. Okay. Regarding that, except from that, exact differentials and inexact differentials, if you have any doubts in understanding what is state, what is a process, what is a path, what is a point function, what is a path function, you can ask me. Meanwhile, I'll be taking your attendance. Abdul Rahman,
Present, sir.
Abhinav, Adarsh,
Present, sir.
Ashanul, Mustafa, okay, Ahmed Reza,
Yes, sir.
okay, Akshay, Amit,
Present, sir.
Amrit,
Present, sir.
Anvit, 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 Ashwin, Ashwin, okay. Ashwita,
Present, sir.
Chandansi,
Sir, he is having network problems.
okay, fine, considered.
Present,
Okay,
sir.
got it, got it. You have a network issue, right? Where do you stay, Chandan? Are you able to hear me, Chandan?
Yes.
So, where do you stay? Okay, no issue. D'Souza, Fahad,
Yes, sir.
next is Faizan.
Present, sir.
Faizan. Next, Gaurav.
Present, sir.
Gaurav. Gautam.
Present, sir.
Gautam. Gaurav done. Gautam. HS. Javel.
Present, sir.
Javel.
Present, sir.
M. Karthik. Yes.
Yes, sir.
Karthik.
Present. Yes, sir.
Yes. Fazil.
Present,
Nasir
sir.
Khan.
Present, sir.
Yes. Noted. Muhammad Shihab.
Present, sir.
Muhammad Tausif Ali. Muaz.
Present, sir.
Suraj.
Present, sir.
Nafa Abdul Rahman.
Present, sir.
Namita Nair.
Present, sir.
Nandesh. Nandesh. Narthan. Niharika.
Present, sir.
Nishchat.
Present, sir.
Next, Nitin. Nitin George.
Present, sir.
Omkar. Omkar. Prarthan Singh.
Present, sir.
Pratish. Suvarna.
Present, sir.
Rajat.
Present, sir.
Rakshan.
Present, sir.
Ramdas.
Present, sir.
Ranjat. Ranjat. Shabat.
Present, sir.
Sagar.
Present, sir. Is having a lot of question. Hello.
Okay. Whom are you speaking about? Sagar? Yes, Acharya.
Yes, sir.
Okay. Shahzad.
Present, sir.
Shashank. Shashank. Shetty. Sujay Jairam. Shetty Tejas Devaraj. Shravan Kumar. Yes, who is
Present, sir.
this? Shravan Kumar. Sriraj.
Present, sir.
Okay. Saurabha.
Present, sir.
Sumant. Sumant. Varun SL. Vigneshwara C. Amit Sangorli.
Present, sir.
Nilesh.
Present, sir.
Rajwal Hegde. Rajwal Hegde. Sandesh. Rachan. Rohan. Varun. Adarsh. Sampreet. And Mohammed Amin. So you said class strength is exactly 60?
So,
Okay. Mohammed Amin present. Okay.
Yes, sir.
Okay. Yeah.
Present, sir.
Completed? Notes
Hello.
writing? Yeah.
Hello, sir.
Who
You
is
didn't
this?
call my name.
Who is this?
Numan Asadi. 4
Numan.
into 16.
Numan.
Yes.
Wait a minute.
It's my first class.
Let me check.
I got
So what's your USN?
4 NT 16 MT 026.
So your name is not listed, man, here. Numan,
Yeah, sir.
your name is not listed in the students list.
Is it?
Hmm.
Okay, HOD.
Okay, just give your USN and your name, complete name. I will talk to HOD regarding this. Okay. Is this your first class?
Yeah, this is my first class.
Okay. Just give your name and USN. Numan
I'll
Asadi.
send on the
Imam Naeem Asadi. I'll send on the chat box.
Okay, fine. You can send it there. Okay, I have noted your name. We have a Dr. HOD regarding this. Okay. Yes. Any of the doubts, guys, in this class? Have you completed taking it down?
Done, sir.
It's 12:30, so done, right? So I'll be just posting my screen as it is. So those who have not taken it can take it. Okay. In the next class, we will be discussing about many of the processes again, which I've just stated, just given a hint of those, which is isobaric, isochoric, isothermal, adiabatic, and polytropic. All those processes we'll be discussing in the next class in a detail. Okay. And I do remember in the last class I have given you one of the assignment, correct? So to get the values of Cp, Cv, gamma, and R of air and water. So let me see who has done that. Ashvita,
Yes,
can
sir.
you give me the value of Cp of air?
Yes, sir.
So what
Cp
is
of air is 1.005.
1.005, correct. And Cv of air,
Cp of air is 0.74.
0.74. R, wait, we should ask the other person now. Faisal, Faisal. Okay, it's already time 12:31. So make sure I will keep asking this values every time. Okay, you must answer this because these values are very important in solving the problems. The Cp, Cv, gamma, and R of air and water. Okay. All the best, guys. Have a nice day. Take care.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you. ಆಯ್ತಾ ಸರ್ ರಿಪೋರ್ಟ್ ಅವ್ರದ್ದು